All right. Well, good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. This is the final live event in our space exploration series. So every October, we host astronauts, but more importantly, the scientists and the engineers who make all of the space exploration projects possible, whether it's sending people to the space station, whether it's looking back at the planet with satellites, or sending probes to other planets and further on into our solar system and beyond. So we have a great event to wrap things up. We're going to spend a little time with Bobak Ferdowsi. He is the fault protection lead on the NISAR Joint Earth Observation Mission with India at NASA's Jet Propulsion Laboratory. His prior positions have included Launch Cruise Approach Engineering Lead and Flight Director on Mars Science Lab's Curiosity rover, Science Planner on the Cassini mission, and the Europa Clipper Mission Planner. So let's bring Bobak in with us live right now. Hey, Bobak, how are you doing today?
Hello, I'm good. How are you guys?
Good, good. It's great to have you joining us. In fact, let's just bring in some classrooms for a big hey. So nice and loud, everybody. Big wave. How's everybody doing today? Awesome, awesome. Great to see everyone. All right, Bobak. Well, we're going to let you take over for a little bit, and then I'll have a little Kahoot quiz working in the background for the students, and we'll do a little Q&A action.
Fantastic. All right, see you guys. Okay, so let's talk about one of the things that I do, which is looking for life in all the right places, as I like to say. And hello, I'm Bobak. That's me as a kid, dressed as a Viking, I think, which is natural because eventually we'd work on Viking missions here at JPL. I also like to dress up like Star Trek, and Star Trek is one of the reasons why I work here at NASA's Jet Propulsion Laboratory today. I think the show just inspired me as a kid to really want to work in space exploration. That's me kissing a robot, which is a normal thing to do, I think, for most people. And I work at NASA's Jet Propulsion Laboratory. We build robotic spacecraft. So as Joe mentioned, right, there's astronauts and scientists and everybody else. And one of the things that we do here in particular is we build the robots that get to explore deeper space and go places where it's still very difficult for humans to possibly visit. That's me working. This is in a test facility a few years ago. And I'll start with the fun parts of this. So this is a planet. This is our planet Mercury. There's also a planet, Jupiter and Saturn, Neptune, our moon. This is also our moon. This is also a moon. This is your Io, Jupiter's moon. This is also a moon. This is Europa, also Jupiter's moon. This is a moon and not a potato. This is Mars's moon, Phobos, and Pan at Saturn, which is not a ravioli, but a moon. This is not a moon, but this is Mimas at Saturn as well, which looks awfully like the Death Star. And this is our planet, which, in my opinion, looks fake after you look at all the other planets. But let's start with our journey with Mars here. So this was one of the first places that I got to work on a mission called Curiosity a few years back. And of course, Mars being our neighbor, it's one of the more exciting places because we think it's a lot like us. And in fact, you can kind of look at it. It's got a rocky surface. It's got these thin atmosphere on it. It's got the polar caps that have carbon dioxide and water ice. So a lot of things that remind us a little bit of home, albeit not exactly like home. And people were fascinated with Mars from a long time ago. When we started having better quality telescopes, right, we were able to observe Mars, and we were able to see these features and dark spots and light spots, and people started letting their imaginations roam, and they kind of saw these as these lines and dark parts as maybe like canals or streets that people had maybe the Martians had made on the surface of Mars. And so of course our fascination grew and grew with Mars. And we wrote science fiction about Martians on the planet and what societies might look like on a different planet. So people were very fascinated. But it wouldn't be for a while until we were able to go there and visit for the first time. And this is one of our first pictures of Mars from a mission that wasn't actually in orbit around Mars, but it kind of launched from Earth, flew past Mars, took a few pictures while it was flying past Mars, and just proved that out. And it's one of the very first interplanetary missions that we've ever done in the Mariner series. But if you look at this picture, and it's a little older and a little grainier, but you don't see very much features that make you believe that there's aliens living on the surface of this planet, let alone that it's a very hospitable planet like the Earth is, right? So it looks pretty inhospitable. You don't see any water features. You don't see anything that makes you believe that we could go there and live there and maybe even thrive there one day. But a few years later, we'd keep going at it, and we'd send a second mission, Mariner. And in this one, you kind of start seeing things that look a little bit more exciting. So there's some craters in here, but what's really exciting is these features that look like this, where it looks like something like a liquid must have flowed at one point in the past and created this delta, and here as well. So you start seeing things that look like they could have only been caused by some sort of liquid. And of course, for us, liquids are the exciting part, right? We think liquids are required for life to survive. So it's pretty exciting. A few years later, in 1976, still a long time ago, but we landed the first missions on Mars. So there were two missions called the Viking 1 and 2 missions. And these were the first missions to land on the surface of Mars and to give us what it would look like, to be on the surface. And the missions kind of were ambitious, right? These are amazing. Even by today, these are pretty amazing missions, but given that they're almost 50 years ago, even more impressive. And the Viking missions landed and did three basic science instruments or experiments on the surface of Mars. In addition to the pictures that they took, the experiments were there to look for life on Mars. And we did a couple things, like we took the regolith from the surface, that's this, the sandy soil, but not really soil in this case, but material, and put them into these instruments. And we tried to, add water and add sugars and see if some sort of biology would react with those things. And, maybe the biology would tell us that it's alive in there. We also look for things that are the building blocks of life, what we call organic chemistry. And so all of us are made up of a handful of chemicals that are all only found basically originally in stars and then get formed into planets. And that's carbon and hydrogen and oxygen and nitrogen and potassium and sulfur, all those things that we need to, to be alive. And we look for those ingredients combined, not just individually, but combined to things that we call organic compounds. And we didn't find them. And the life reaction, experiments didn't work. And so, you go there with the hopes that maybe, your neighboring planet, which kind of seems a lot like you, maybe it'll have life on the surface. But sure enough, right, our first two experiments on the surface of Mars didn't show anything. That's a little bit of a bummer. So it would be a while before we go back, but starting in the 1990s, we started sending more and more rovers. And what became more and more interesting is that the story is not quite as easy, simple as we started with. So this is the mission I worked on. We landed this one in 2012. It's called the Mars Curiosity Mission, or Mars Science Laboratory, as we initially called it before it had a cooler name. And this mission was the first to sort of look for habitability on Mars. When that question is whether life could have survived on Mars, not whether it exists right now, but just the very first part of that question: can it exist? And what was pretty amazing is within the first few weeks of landing on Mars, we were able to take samples. And here's a picture of us at a site called Rocknest, and you can see we've scooped out some of the sand on the surface here. And we've ingested that sand, and we ran it through our chemical analyzing instruments, and we inspected it up close with microscopic imagers. And what we found was pretty good news, right? Which is that this initial area of Mars that we landed in definitely used to have water. We think the water would have come up to anywhere between, ankle to waist high. So a good amount of water, not just maybe there's it's wet on the ground, but actually standing water. And that water almost certainly contained the ingredients that life would have needed to survive. So you have a good part of the story here with now, could life have survived on Mars? And again, in that water environment with the chemistry that we see, the temperatures that Mars sees, right, the warmth that you need for life, it's a good chance that Mars could have survived, could have had life at one point. So we would follow that on with a mission called Perseverance, which I didn't work on, but that mission in particular is now gathering samples to bring back home to Earth. And so here on Earth, where we can do much more detailed analysis, we'd be able to look for more evidence of life. So what do I work on today? I work on a mission called NISAR. This is us getting ready in the clean room on the left-hand side. This is our actual spacecraft in the clean room on the right-hand side. This is an Earth science mission, the first one that I worked on, but right here we're going to be looking at trying to understand what our planet is doing. But that's kind of what I'm up to today. It's just an amazing part of a mission to be part of this build-up and development, because it takes us anywhere between 5 and 10 years to start building out these spacecraft, from the time that we start designing them to the time that we start assembling them and then testing them. And so for this mission, I joined in 2016, and we will launch in 2024. So it will have been on there for 8 years of my life at that point. So, but still really cool. This is one of my favorite pictures that I've ever taken. It's a sunrise on Mars. So this was just a beautiful shot that I was very proud to have been a part of on the Curiosity mission. I just wanted to include that for context and to kind of take us back to why exploring? So one of the other missions that I worked on that's getting built right now is called Europa Clipper. And Clipper is going to a moon of Jupiter, and we're looking for a few things here. We know Europa is an icy moon of Jupiter, so the first thing that we know is it has water. But we're going to try to understand what the state of that water is. The next thing is we want a source of energy. That means warmth in some cases, like for us, it's the sun. But also on Europa, where there's an icy surface, but maybe water below it, could that warmth come from a warm interior, right? Like a core that's still very hot from its formation? Could it form from things that are slowly decaying in the interior and giving off heat? But life needs a source of energy. Then we need the chemical ingredients, right? We want like all the goody things, like I mentioned earlier, the carbons and the potassiums and all that science stuff to get there. And we need time. We need those ingredients to mash together enough times that eventually all the ingredients mash together in just the right way that ingredient wants to reproduce itself with other ingredients, and eventually that gives rise to life. So this is Jupiter taken by the Cassini spacecraft as it flew past. It's an absolutely beautiful shot of Jupiter. This is what Jupiter looked like to Galileo when he was first looking at the planet. And one of the things that he was fascinated by was he would see these stars around Jupiter, and he would mark down where the stars were around Jupiter each night. And it was very obvious from looking at where Jupiter was in the sky and how these stars moved around it that these weren't stars actually, but objects moving around Jupiter. And that's what gave rise to one of our understandings that not everything orbited the Earth, but in fact, things could orbit other bodies. And perhaps it was possible that the Earth itself was orbiting something else. But these stars on here represent the moons, the 4 moons of Jupiter that we could observe back in Galileo's time in the 1600s. But that we call now the Galilean moons, and the 4 biggest moons of Jupiter. In fact, they're so big that they're much bigger than our moon. And this in particular is the moon Europa. So this is the second of the Galilean moons in terms of distance from Jupiter, and it's kind of in Jupiter's Goldilocks zone. So in particular, right, we've got moons that are very close to Jupiter, but because they're so close to Jupiter, they get really, really hot. By moving around Jupiter, they kind of get like, if you imagine the tides on the Earth, right, the water is rising and falling and rising and falling. But if that happens at a moon scale, it basically compresses and expands and compresses and expands, and all that compression expanding gets it hotter and hotter and hotter. And it actually, Io is one of the most volcanic moons that we know of. And then beyond Europa, we've got Ganymede and Callisto, and they're a little farther out, and they don't get as squished and expanded, and therefore they're much colder and also more likely to be more solid ice. But Europa is sort of in this magic Goldilocks zone, and it is right at the kind of the right sweet spot around Jupiter where it's getting compressed and expanded just a little bit, enough that we think it's causing it to warm up and to melt the ice below the surface. And that liquid below, that water below the surface would be the ocean in which possibly life could exist. So let's take a look at that. So that's Europa going around the Jupiter, and you can see that kind of orbit this moon. And so one of the things we can do is go fly by Europa over and over again, and hopefully measure what's going on there. And early on, we had a mission called Galileo that went to Jupiter, and what Galileo was able to prove through magnetic measurements was that Europa had liquid water. So that's the Galileo spacecraft being launched out of the shuttle. That's another picture of that. I don't know what these pictures are. All right, here's a close-up, for example, of the Europa, and you can kind of see one of the interesting features here are these cracks that have formed in the icy surface, and then you can see there's like movement, and there's cracks like this one should be connected to this, but it's not. So that also tells us that this icy surface is not static, that it's moving in some way, and that gives us the idea that there might be something below it moving it, right? Like on the Earth, we are on tectonic plates, and there's magma below us, and so we're floating islands effectively on the surface of the Earth. And here, these are big, basically giant ice islands that might be floating on the surface of Europa. All right, so these measurements are the Galileo measurements. And if you've ever walked through a metal detector, for example, metal detectors are kind of cool, right? The way they work is that they put out a magnetic field. And if you have metal on you, that magnetic field interacts with your metal and creates basically a sympathetic magnetic field within the metal that you're wearing or carrying on you. And that's what the detector detects. In Europa's case, Europa's flying through a magnetic field, which is Jupiter's magnetic field. And what we could tell when we were flying past it is that it's creating a magnetic field of its own based on Jupiter's magnetic field. So that tells us there's something about Europa that allows these electrons to flow, to allow this kind of metallic behavior to exist. And one of the best ways for that to exist is a liquid medium in which there's something like salts or whatever dissolved in it. And this is what I mentioned earlier. So as Europa compresses and expands, we think it kind of warms up a little bit, and that creates these layers. So there's an icy outer layer and a rocky inner layer, but right between those two is hopefully what we believe to be a liquid ocean. What that might look like, we're not exactly sure. So that's one of the things that we want to go there to explore. Is it a thin icy shell and a big massive ocean below? Is it a thick icy shell and a smaller ocean below? We just don't know those answers until we go there and start measuring them in person, or in this case with robots. These are the magnetic fields, as I mentioned there. Another thing that we notice with visiting here is that we see Jupiter has these intense magnetic storms. So that's why we know that the magnetic fields are coming from Jupiter, but then also we can tell which ones are coming from Europa. So we're doing that with a mission called Europa Clipper that's also getting built right now at JPL. And that mission flies around Jupiter, but flies past Europa every 2 weeks. And these big poles that you see sticking out here are radar, and those radar allow us to penetrate through the ice and to measure how thick the ice is and where the liquid ocean might exist. And that's the orbit pattern that we see around Europe. So you can see there's Jupiter right in the middle. Here's the orbit of Io, and here's the orbit of Europa. And you can see we do these big loops to stay occasionally and revisit Europa timed over time. It's sort of a dance around the planet and moons. The other thing that we're hoping for with the Hubble imagery that we've seen recently is the potential that Europa has liquid water that's occasionally spouting out of Europa. So from things like these big cracks, could liquid water be shooting out occasionally? We've seen that at other moons like Enceladus, but we haven't necessarily been able to confirm it with Europa. And if that looked like that, it would look like something like this, right? With these big geysers that occasionally erupt from Europa. And if we're fortunate and there are such things, when we fly around and pass Europa, we'll be able to measure some of that water and look for direct measurements of what that ocean might look like on the subsurface of Europa. Yeah, so this is a breakdown of the spacecraft and the different instruments that are happening on there. And again, these are the radar measurements that we hope to take, right, by looking for the subsurface water. This is one of my favorite posters. We have these beautiful art posters. So in this case, we did a nice, what would the life under the ice look like, and what could it be like? But as we look at the solar system, Europe is one of the more promising places. So in addition to Mars, which was kind of in the sun's Goldilocks zone with the Earth, now we're beginning to realize that these moons of planets may also be in the Goldilocks zones of their worlds. And I have no idea what that life looks like, but if you look at deep surface of the Earth, we do see that even near the floor where it's very dark, this is lit by the submarine that's taking the image, but these are very dark places, and there is life that is in abundance even at the very bottom of the ocean floor on Earth. So after that mission, we're hoping one day to send a landed mission that might more directly take evidence of that. We're also working, the mission is called Europa Lander. And as I mentioned, one of the most exciting things is that this opens up a whole realm of possibility for us for where life might exist in both in our solar system and potentially in other solar systems around the universe, is these moons of other places. And I'll leave you, with this picture. So this is Enceladus. So this is a moon of Saturn where you can see the geysers erupting. And again, the kind of hope that we have. So I really love that that image. So beyond that, of course, this is a beautiful photo looking back at us and why we do this all. This was taken by the Voyager spacecraft as it flew. This is around the distance of Jupiter. These color bands are actually due to how the camera sensor works, but that is Earth from that distance, a very tiny speck. And so much of what we're doing really is about understanding the context of ourselves. Are we alone in the universe? Is it the only life that we're looking for? And we really hope that the answer is, of course, that we're not alone in the universe, but there's only one way to find out, and that's to explore. All right. Thank you.
All right. Awesome, Bobak. It's you get to work on some pretty amazing projects. And I think that's, the cool thing about your job is you may spend several years on one project, but it seems like you get to move around a little bit. You have a hand on a few different things. So I think it's the kind of job that you never get bored.
It's definitely, yeah, no boredom here. And I was even late today, right? Because we're having a spacecraft problem, and I was like trying to dive into the details and figure it out. And it's fun, right? Because your job takes on these things of like building something, of course, and testing it. But then some days you're a spacecraft detective, and you're trying to look at these little clues left by the spacecraft as to what's going on, figuring that out, and then hopefully you get to save the $1 billion mission from disaster.
No pressure.
Yeah.
All right, awesome. Well, I've got a quick Kahoot quiz here whipped up for the students. So I'm going to share my screen quickly. But before I do, I'll put up the address here. Actually, this is an old one. Let me just change the PIN number. There we go. So here is the address, kahoot.it. Once you get there, it's going to ask you for a PIN number. I'm going to share my screen. That is going to bring up a PIN number for us. So bear with me for one moment. There we go. So our PIN number for today is 952879. I can see a few students or classrooms have already snuck in. That's awesome. So if you have one-to-one tech, use that at your seat and you can come in and join us. If not, your teacher could pop it up at the front of the room and you can shout out your answers to him or her. If you are using a mobile device, you can scan that QR code. It'll bring you right in. You can see the names are being picked for you. We've got the funny quail, the smart bobcat, the crazy piranha. So lots of cool animal names coming in here. 20 seconds for each question. There's 4 of them, some multiple choice, some true and false. Get the right answer, you get some points. Get it in quickly, you get even more points. Get it in, but put in the wrong answer really fast, you still get nothing. So think about those answers as you see them pop up there. We'll give it a couple more seconds because I still see lots of students joining, lots of classrooms popping in. And then we will get things started and we will wrap up with a little Q&A with Bobak, and then we'll let him get back to the spacecraft issue. Hopefully they get it solved. Okay, it looks like things have calmed down, so let us get the live quiz started. Here we go. Our first question is a multiple choice. And it's which mission did Bobak not work on? So we talked about a few missions in the intro and during the presentation as well. Was it Cassini? Was it Voyager? Was it Curiosity? Or is it the Europa Clipper? So which of those 4 missions has Bobak not worked on? All right, good job, crew. Although Voyager is still sending back signals, Bobak, is that one that you have not worked on, I'd assume?
I've not worked on
it.
A
long time ago.
Yeah.
All right, very cool. What does that do to our leaderboard? The legend shark is in first place, and we actually might see a few sharks when we visit Mr. LeVog's class in Florida shortly. Let's go to our next question. This is a true and false. Liquids on another planet or moon don't get NASA scientists excited. So liquids on another planet do not get NASA scientists excited. Is that true or is that false? I have a feeling our students joining us today are too sharp to let this one slide by. But 2 more seconds to get your answer in. Oh, wow. We tricked. Or no, we are right here. It is false. They do not. Or sorry, no. It goes on another planet. Don't. Okay, yeah, it is false. I'm even having trouble reading that question. But yeah, right. It is false. Liquids definitely get scientists excited on planets, on other moons, because it does hold that potential for those ingredients for life and maybe life. So the classy ant has slipped into first place. Let's go to our next question. It's a quick true and false. Curiosity found evidence that there was once water on the surface of Mars. Is that true or is that false? Did Curiosity find evidence that there was once water on the surface of Mars? Bobak, how is Curiosity doing? Or is it still sending back some information?
Yeah, great. 10 years old now or 10 years on the surface of Mars, still sending back a lot of data, and still traveling to new exciting places.
Awesome. Well, that is 100% true that it did find some evidence that there was once water on the surface of Mars. The classy ant is holding on, but this final question, it was going to decide everything. So, oh, well, that didn't come in properly. But this question should be, what is Europa Clipper looking for? Is it looking for water, chemical ingredients of life, an energy source like in the interior, or all of the above? This question is going to be a bit of a, we'll see how the classrooms do. Okay, they got it. Good job, crew. Most went with all of the above. And what does that do to our podium? In third place, we have the Space Dog. That fits
good
very
name.
well with today. We've got the Lively Lark in second, and holding down that top spot. What happened? Oh, the Classy Ant held on strong. Good job, crew. Thanks for playing along with us. Let's switch over and let's wrap up today with a little Q&A action. So I'm going to kill this share here. And we're going to bring in our first live classroom. We've got Mr. Elsa's crew hanging out with us in Burlington, Ontario. They're 6th graders. And in Ontario, that means they are studying space exploration this year. So let's bring them in front and center. How are we doing, grade 6s?
Good.
All right. We're ready for you.
Hi, my name is Luca, and my question is, why do you guys want life on space?
Well, well, I mean, I think it's just a lot of us hope we're not alone. We want to look at the stars and other planets and kind of hope that we're not the only place out here with life. So when I look at the night sky, what's kind of amazing is, now when you see stars, we believe that most stars have planets around them. And so just the number of planets out there and the number of moons around those planets gives us all a lot of hope that there's life. And so it'd be nice to be able to feel positive that somewhere even nearby there's life, and that the odds of life aren't just 1 in trillions, but maybe 1 in millions, which means, when we talk about billions and trillions of stars, there'll definitely be life elsewhere.
Okay, thank you.
Awesome.
Well, thank you.
Great question. And I think, we can learn something about life on our planet if we can find planet or life on other planets or other moons. But let's squeeze another question from our grade 6s in Burlington.
Hi, my name is Simon, and did the DART project do anything yet?
Yeah, so the DART mission was a mission to impact an asteroid. It's an asteroid that's orbiting another asteroid, so basically a small moon. And so we smashed into it like a month ago, and the intent there was to figure out if smashing into it could move the trajectory. And what we saw was very quickly that we've changed the orbit of the small asteroid around the big asteroid, and not that the big asteroid's day is a little longer now than it used to be. Or sorry, it's a little shorter now than it used to be. So we already know that we've made a pretty big impact. We thought that was only going to be a little bit, but it's actually about 30 minutes of rotational change. So imagine if your day got 30 minutes shorter every day. And so we're going to still track the motion of the asteroid around the sun to get the final details. But I think that the good news is a really good demonstration that if we have to divert an asteroid from hitting into Earth, we kind of know the approach to doing it. And if we discover it early enough, we'll be able to safely move it out of the way of Earth.
Okay.
All right. Great questions from our grade 6s. If you were tuning in via YouTube, I can see we've got groups hanging out there. Shoot your questions in there and we will work them in. And then I promised some sharks in Florida. So Bobak, here we go. Let's bring in the shark.
Oh!
Go ahead.
Below the surface of Europa somewhere.
Go ahead. Go ahead, Finn. Ask your question.
I was wondering if you had a chance to explore anywhere in space, where would you go?
Me personally, or with a robot?
Oh, what do you want? What do you think? With a robot or him personally?
You personally.
I would pick Mars. I think that would be the most exciting, mostly because I want to go see the robots that I built, like just sitting there and doing their thing. I think it would be cool to see them again after so long.
All right, let's grab another question from Florida. Kenny, let Avion out.
What was your best day at JPL?
Oh, my best day at JPL? I think the day that we landed the rover on Mars was probably my best day. I'd spent 9 years getting to that landing and working on that mission, and that was the moment where it was either going to be successful or not, and thank goodness it was successful. But that, yeah, putting that much effort in and finally being like, it worked, that was pretty amazing.
All right. Awesome. Thank you, Florida, and thank you, Sharks. Very cool. Do you want to squeeze a question in? It looks like you want to squeeze one in. Do you have one there on your card?
Yeah, we have another one.
Yeah.
Okay, squeeze it in. Squeeze it in.
Excuse me. Do you work at odd times of the day when you're working on a specific mission?
You work
Well,
at,
one more time.
do you work at odd times of the day when you're working on specific missions?
Oh yeah. So yes. Once we were on the surface of Mars, Mars has a 40-minute longer day than us. It's got a 24-hour and 40-minute long day. And for us to be working while the rover was sleeping so that we could plan the next day, we would move our day every day by 40 minutes. So the first day I would show up, like say 9 a.m., the next day 9:40, and then 10:20, and then 11 o'clock. So my day would slowly move. Every 36 days, it would circle back around to the start. So I was living on Mars time, as we call it here. So for 90 days of that mission, we all lived on Mars time.
All right. Thanks for that. Great question.
Yeah, that was really cool. Thank you.
All right. We are going to, I can't tell, Mr. Shattuck's crew in Sudbury. Looks like they might have had to go out for recess, but let me see if anyone's in there. No, it looks like we might have lost them to recess. So we'll come back and see if they come back in before we wrap up today. We're going to go to California, though. We have a classroom hanging out with us in San Jose. Looks like some fifth graders. Let's bring them in front and center with Mr. Sinclair. How are we doing, fifth graders?
Okay. Go ahead.
How many missions have you worked on or been on, and which mission was your favorite?
Okay, so I worked on Curiosity, Clipper, NISAR, Cassini, and Kepler. So 5 missions. So far, this is my favorite, NISAR, the Earth orbiting mission. It was amazing to be part of a Mars mission, but this is the first time I've been able to like have a vision and then make that vision be implemented. On previous missions where I was helping people. So it's pretty amazing to like to see the spacecraft and be like a lot of that came from my mind and is what it is today because of things that I decided on. So it's really cool. This is probably the most me spacecraft that I've ever been a part of. So I don't know. That's pretty neat.
Yeah, I think so too. And I think a lot of people think of spacecrafts and think going out in the solar system, but it's just as important to look back and learn things about our planet. Okay, go ahead.
My question is, where do you think is going to be your next in-person destination?
Oh, well, I mean, the cool thing is a lot of people get to go now slowly but surely more and more to Earth orbit. So one of the cool things with the rise of, much more affordable rockets is that it means a lot more people can afford to go to space. So I think that's going to be the next place for a lot of us to go. Personally, if I could pick, like a place with a not too long a trip, the moon would be amazing. I would love to see the Earth from the surface of the moon, and that's just a couple of days. Once you talk about getting to Mars, you're talking about like 6 months to get to Mars, so that's going to be a very long trip, and I think I'd get bored sitting inside of a rocket for 6 months. But yeah, going to Earth orbit or going to the moon both seem like things like for a lot of us that we'll get to do in our lifetimes, maybe.
Thank you.
Thank you. Awesome questions. Do you want to squeeze one more in before I go to YouTube? Is there another question there?
I was wondering if you ever felt like the rovers were almost like alive or thinking.
They definitely have personalities. I don't know if they're alive or thinking, but they definitely misbehave, even though we designed them and we think we understand everything about them. Just anytime you make something like this complex and so many moving parts, there's just things that you don't, realize. So sometimes when the spacecraft isn't working, or any of the spacecraft that we worked on don't work correctly, I'm always like, it just feels like they're misbehaving, and like they have their own personality. And I always joke that it's like, does the spacecraft need a hug? Like sometimes I'm like, maybe that spacecraft just needs a hug and it'll feel better.
All right, cool question. Thanks, San Jose.
Bye.
All right, let's grab a quick question or two off YouTube. This is a class in Canada, grade 4-5s in Erin, and they're wondering how long you've been working at JPL and have you ever worked with astronauts?
I've been working here for 19 years. And I've worked with astronauts, but not on any of the robotic spacecraft that I worked on, but just on like personal projects or things like that. But Houston Space Center or Johnson Space Center is where they do most of the astronaut program. And there's a couple people here who work with astronauts, but yeah, we're very focused on places that are, robots can hopefully do the job.
Yep. And I saw a photo of you and a certain movie astronaut, Matt Damon. So was that some consulting for the movie?
No, that was after the movie had come out. He came to visit us at JPL and just got a cool tour, and I got to show him the Mars yard where we get to test the rovers. But he had a great time, and I think it's been very fun. One of the cool things about being here in LA and working on these cool missions is, of course, a lot of people from Hollywood want to come and visit us and see it. But some folks do come out here for research for their movies. And we've had a number of directors and writers come out here, as well as some of the actors who are researching, roles that they're going to have for space-based movies.
All right, awesome. Well, we're close to wrapping up for today, but give me a wave in your classroom, and maybe we'll squeeze in 1 or 2 more questions if you have another one there. I think Mr. Elsa's class, you didn't get a third question, so we'll let you have one there.
Hi, my name's Olivia, and I was wondering if it's true that the Andromeda Galaxy and the Milky Way Galaxy are going to collide in 5 billion years.
Yeah, I don't know. I don't remember how long it is, but it's a long time ago, and the two will collide is maybe the wrong term, but they will pass through each other. Just if you think about our galaxy, right? The next star closest to us is 4 light years away. So if the sun is 8 light minutes away, so you can think of how big a light year is. And so most of it will be empty stuff passing through empty stuff, but a few things will tug on each other, right? Like a star might tug on a star that is passing closer to, but it'll be mostly just kind of passing through each other more than colliding.
Okay.
Yeah.
All right, cool question. Is that someone sneaking in for another one? All right, go for it.
Hi, I'm Rachel, and I was wondering, if you did find life on Mars or another planet, what would you do?
We'll probably get really excited. I know that everybody thinks we would somehow keep it a secret for a while, but if you've ever met scientists or engineers, we're really bad. We get way too excited too easily about those things, and we would not be able to keep it a secret. So I would imagine that very quickly we would, make sure that the data was truly, confident. Like there's no way that we messed up the data and like thought it was life when it wasn't life. And then we would tell the public, probably in what looked like it was going to be a very boring press briefing. And it would be one of the more exciting press briefings of our time.
All right, very cool. Great questions from our 6th graders. Good luck with your space unit. Okay, Florida, do those sharks have any more questions? You have one more for us.
We do have one more.
Okay, go for it.
That's okay, Joanna. Go ahead. So she was asking about, we talk a lot about failures.
Yeah.
Can you describe like something that didn't go right, and then like what you took away or what you learned from it?
Oh my gosh. Well, if you remember the introduction, I'm the fault protection lead for this mission, which is actually how do spacecraft fail. So that's I love talking about failures. I'll give you a couple of examples, but one of my favorites is one that is it's kind of well known, and it's how we lost the Mars climate orbiter a few years ago, and now 20 years ago or so. And that one's very famous because that mission was one of the first missions that we were sending back to Mars after this, the 1970s, and we haven't gone a long time. We were excited for the resurrection of the Mars program, and we went there, and very famously, it's the one where we messed up our measurements, and we basically took the propulsion system was designed with using the imperial system, so using pounds and feet and things like that, but the navigation system was designed using newtons, so things like kilograms and meters and things like that. And so when the software code took the data input, it wasn't aware that it was being provided inputs in the wrong units and took the inputs as the units it was expecting, right? So it was taking imperial units and making them, intellectually thinking that they were metric units. And so the end result, combined with a number of other issues, we should have still been able to figure all this out, by the way. But that issue is one of the big ones. And so one of the big lessons learned, of course, is be very specific about what we're communicating, right? And that doesn't just mean with units. That means make sure that when you describe, you're using a word like downlink or using a word like active, what does it mean? Make sure that it's really clear what you're communicating, and so that both parties are very, on the same page about those things. So that was a huge lesson learned for us. And now, of course, we actually have made everybody move to metric. So we don't use 2 units, so that one hopefully will never be repeated. But that kind of thing can happen in all sorts of different environments, making sure that you guys are on the same page. That's the first step, I think, in all difficult engineering, is because 2 people and their brains have great models, but then making sure we understand each other's models is the hard part.
Thank you.
Yeah, great question.
San Jose, do you want our final question today? Do you guys have one more? Our 5th grade class? Probably not too far from Bobak.
Yeah, I grew up in Oakland, guys. So
I had a quick one for them.
Yeah.
This is Mr. Sinclair. A couple of them were asking, when you run into failures, how do you find your way through it? Because that's something a lot of us struggle with when we're working in our environment here.
Right. So first of all, I do my best, obviously, to avoid it, but it's impossible, right? Even talk about, the number of people who are looking at things together, right? We're working as a team, and it's still possible, even with a team, for things to slip through the cracks. So the first thing I try to remind myself is it's nobody's fault, right? As a team, we worked on the thing, and remember that, like, all of us kind of share the responsibility, whether it's successful or it's has a failure. And the next part is, I really do try to dwell on the failure and to really figure out what happened and what went wrong in that situation, or what went wrong with the technical part of it. Because, again, if you're successful, it's fantastic, but the failures are the ones where you really get the lessons learned, right? Like when we talk about missions that didn't work at JPL, those are, like, we don't talk about all the missions that were successful and therefore we should just do it the same way. We talk about the missions that are failures, and we try to figure out what didn't work, what lesson do I need to take from that so that I can make sure my next one is successful. And I think the really cool thing about engineering is you can have all sorts of failures. Some of them we're fortunate. Like today we had a failure, I would say, right in our system, but we were able to recover from it, and it's going to be fine. We're still going to go back and try to understand, even though we got out of that problem, we're still going to go back and look at the problem and say, what happened in there? How do we avoid that happening the next time we do something like this? And again, that's so much more valuable than if it goes successfully, but we miss something, and then the third time we do it, that that thing that we missed comes back to catch us, right? And so that's, to me, the failure is actually, like I said, the most exciting part of this. Plus, I think the cool thing about failure is you really, really try to force yourself to understand how things work. Like, I bet, by myself included, before I worked in this area, I would not have been able to really tell you how a computer works. But now, because I've had to look at every aspect of how a computer can fail, I can tell you a lot about how computers actually work successfully most of the time. So through failure, like I said, I think we learn more than through success.
All right.
Thank you.
Awesome stuff.
Hi, guys.
Well, I want to start off with a huge shout out to our classrooms today, to our camera classrooms, to our classrooms joining on YouTube. Thanks for the great questions. Thanks for playing along with the Kahoot. And Bobak, thank you so much for being with us. We always love stealing some of your time, sharing some of your adventures and the work that you get to do. And yeah, I'm so grateful for your insights and what you shared with us.
Thank you. And I can't wait to share all the exciting science that comes out of the missions that we're working on now. So please keep an eye out at all the cool stuff that we're going to do at NASA over the next couple of years. And I'll come back to share more about it.
Excellent. Well, we've got a few classrooms still sticking with us.
Awesome.
So let's give a big shout out, a big goodbye, and thank you from some of our camera classrooms. Thanks, guys. Great to have you. All right. I hope everyone has a great weekend. We're going to sign off for today. Thanks, everyone.
Hi, guys.